Hi everybody, welcome to the Manifold channel. We're going to continue our David versus Goliath series of videos, and this is a David versus Goliath part 3. And if you remember from the previous two videos, what we did is we compared the hardware of a big-time 48-thread Threadripper machine, a tower machine with all kinds of cooling and other cool gee-whiz stuff, to a tiny little mini-ITX board. And now we're going to see how the two different systems compare in terms of performance. What we're looking at right here, courtesy of remote desktop, is the 24-core Threadripper running 48 cores. As you can see, it's an AMD Ryzen Threadripper 2970WX. That's a second-generation Threadripper, so it's kind of a discount Threadripper, but it's a great value way of getting 48 threads, and it's actually a very fine processor. And what we're going to do is we're going to redo the rendering shootout video that we did with comparing ArcGIS Pro rendering to let's put that right there, let's minimize that, and to how Manifold runs on the tiny little mini-ITX board. And what we're looking at here is a project that I've opened up. It's the same project that was used in the rendering shootout video, and what it is, it's all roads in the United States, the US GDT roads layer, and I'm going to turn it on right here. I'm going to click that button. You can see how fast ArcGIS Pro renders it. And this is coming in from a file geodatabase. That's ArcGIS Pro's native file storage. And as you can see, it's rendering the stuff reasonably well. I wouldn't call it quickly, but it will take forever to render the entire United States. It's pretty slow at doing that. And while that's doing that, let's see how fast Manifold does on the little mini-ITX box. So let's go over here to remote desktop. I have another remote desktop session running. I'm going to click that, and here's our remote desktop on that tiny little mini-ITX board that we showed in the David versus Goliath videos parts 1 and 2. And as you can see, this is a Ryzen 3 4300GE with readout graphics. It's only 8 threads, 4 cores, 8 logical processors. So it stands to logic that a tiny little budget machine here compared to the multi-$1,000 Goliath would be slower. Well, let's see how fast Manifold runs. And we have exactly the same project here. In fact, it's actually a project that is twice as large as the project that's running on the Threadripper, because it has all U.S. roads in one big layer. Then it has all the states in as multiple states layers. So let's turn that on, and that's how fast it renders. Now, you keep hearing a lot of pushback on the internet saying, "Oh, well, that's all cache memory," but that's not true. Let's right-click and drag to zoom to an arbitrary extent, and you can see that it's zooming instantly. It doesn't matter where we go or what sort of zoom level we do; it's still going to zoom instantly. And let's right-click and drag. In fact, the slowest thing in this is Bing Street Maps is taking a while to load because it has to load tiles from the internet. So let's turn that off. And as you can see, as fast as I can move this map to anywhere, it'll instantly render, no matter how many lines there are on screen. It's obviously a bit faster when there are fewer lines on screen, but still, if we control-click on the tab to zoom to fit, you can see that it renders absolutely instantly. And this is a Ryzen 3 on a box that costs, almost nothing to put together compared to that giant Threadripper tower server-style box that we created. Here we are in New York. Here's Manhattan. So okay, let's control-click on that. Let's see how fast it takes. And now what it's doing, by the way, if you look into the layers pane, we can see that these are multiple different layers. There's like 50-plus layers, one for each of the states. And if we like, we can go to here, the U.S. roads layer, which is just a single giant layer. As you can see, that's 22 million roads, all 22 million roads in the United States, all in one layer. That's slightly slower to render because the Ryzen can't use multiple cores to render those, all 8 cores in parallel. But as you can see, it's still plenty fast to work with. And this particular project, let's turn both those layers on. And let's turn that on. Let's zoom to fit. And you can see it's actually rendering those in. In fact, if we force it to slow it down a bit by, let's turn that layer off and turn this layer off. And now let's turn the rows layer on, and let's turn this layer on. You can see it takes a few moments to render those in. So it's not pulling it from cache. It's actually pulling the data in from storage, and it's rendering it that fast. Manifold on a Ryzen 3 is really that fast that it's doing all this stuff instantaneously. What we were seeing here, by the way, when we let's go back one view. For these views here, those are moire effects from the two different layers that are coming approximately the same, with kind of fine differences in how the layers being rendered to account for all these millions and millions of lines on screen that are more than can fit into the single pixel. Now, if we go back and we go back to our session with Arc, we can see that Arc has finished rendering this. And if we start zooming in, you can see that Arc will do a better job at zooming those in, at rendering these lines. But you can see that it won't even render part of a single state as fast as Manifold can render 44 million lines in all those layers throughout the United States. I mean, we're still waiting for it to come in from here. Let's zoom out a little bit using the mouse wheel. Let's zoom in like that, and there you can see how fast it's rendering this stuff in. So I think that's kind of proof positive that ArcGIS Pro on a mighty 48-thread Threadripper runs way slower than, say, Manifold running on a inexpensive, tiny little mini-ITX box. Let's zoom to fit. Bang, it's done. All right, let's try something else that's also more interesting. While all this was going on, I was actually running another Manifold Session, and here it is right here. And this is a Manifold Session which is working with a raster. And if we look at the info pane, we can see that this particular raster here, turn it off, turn it on, is 26,200 by 37,700 some odd pixels. So it's not a big raster as far as Manifold raster standards go, but it's pretty big for Arc. And let's zoom into someplace interesting right here. And what we're going to do is we're going to build contours. And we're going to redo the contour demonstration that was done on one of the videos. And to do the contours, I'm going to click on the transform pane here, and I'm going to choose the target, this the subject of the transform pane, this raster layer, and I'll use the tile field from that layer to call up all the different transform templates that can work with tiles, that is rasters. And one of them is this contour guy right here. So let's turn on to the contour, and what we'll do is for the output type, we'll choose lines. I want contour lines, so I'm going to use the tile field channel 0, which is what gives us the elevation for this raster. And I'm going to go from about let's go from 600 whatever it is, meters or feet, to 3,200, and I'm going to do it in steps of 100. And we'll round the start and end to step, and we'll split into shapes, which means instead of each contour being one incredibly complicated line object, it'll split it up into multiple different polylines where the contour is not disconnected. So if there's a contour that goes around here, and another one that goes around here, there, and another one that goes around there, those will all be separate line objects, and not just one with 3 different branches. And we'll put the result into a drawing called contour. Right, I have to spell that right. And here we'll use that as a table. Let's put that into a contour tiles. And if we like, I can do a preview to see how fast it'll go. Let's do a preview because it doesn't take that long. In fact, on this itty bitty machine to do contour tiles for that entire raster takes 15 seconds. On the Threadripper, it takes about 10 seconds. So this is a little bit slower than the Threadripper, but not terribly so. There you go, it's done, and that's giving us a preview of what the contours look like. And to actually do that, I can split the preview here. Let's go. Let's split screen it to see part preview and not part preview. It's kind of like the Esri reveal thing. It's kind of pretty cool, I have to admit. Okay, let's hide the preview, and let's do the transform for real, and that'll actually build a new, I guess what as we call a new feature class, and that is a layer with polylines in it that have polylines from 600 to 3200 with a step every 100 that do the contours for all these. And as you can see, that took about 15 to 16 seconds. And there in the project pane is what we've created. Let's drag and drop that into the map. So you can see it really did create contours for the entire entire raster surface that quickly. And as we zoom in, you can zoom into any of these places. You can see the incredible detail of all these contour line objects that was created. Now, if you try this in ArcGIS Pro, and you can do it, you can actually download this data set. Manifold provides it on the product downloads page. You'll see that it takes Arc about 20 minutes to do the same contours. And that's you don't have to take my word for it. Download the data set, download the zip file. The zip file with the grid file for Arc is I think about 4.5 gigabytes, something like that. And unzip it and import it into your Arc license, and you'll see it really does take 20 minutes to do contours. And here on this itty bitty little Ryzen 4300 GE with Radeon graphics and a mere 4 threads, it takes it 16 seconds. So I hope you've enjoyed the shootout. You can see that the tiny little mini-ITX board from running Manifold is indeed dramatically faster than this Titanic Ripper here. Let's turn that off and zoom in. Let's turn that back on again. It's faster whether it's rendering, it's faster whether it's doing computations on rasters, on vectors, or pretty much anything else. And that's despite the fairly the attempts at by Esri to do parallelization in ArcGIS Pro, which, by the way, I want to emphasize is a fine product. It's a really great product. I enjoy it a lot, but it does have problems with performance. It's not remotely as fast as Manifold. So you can throw a lot of money into hardware to try to make ArcGIS Pro faster, and it's still not going to be remotely as fast as Manifold is. And just let's do that one more time. Let's turn that layer off and then turn it back on again so you can see, bang, it renders instantly. Thanks for watching. I hope you've enjoyed this video. Remember, you can save a lot of money on hardware and also get a way better user experience in terms of response by choosing Manifold. Hope you've enjoyed this video. Tell your friends, and goodbye from Manifold Land. Well, that was fun. If you want to see more, visit us at www.manifold.net. As always, Manifold delivers the world's most advanced, highest quality spatial products for GIS and DBMS at a low price that you can afford. Once again, that's manifold.net. See you soon.